This is section 11.4, Mathematics of Finance. This is where we're going to get a couple different formulas for the different types of accounts we may have, such as annuities. That's basically what we're talking about today is annuities. So I'm not going to read the top to you. You can read that on your own. Here's our formula. You'll be given these formulas on the test and stuff. You don't, or you should write them down on your note card. That's what you should really do. Here's our formula for the amount of an annuity. N regular payments equal payments of size R. Interest rate I per time period. So that's where things get a little different. So if we go down to the first one, an investor deposits $300 every December 15th and June 15th for 11 years. So our R is $300 that we're depositing. It earns interest at a rate of 10% per year. But how many times are we doing it per year? We're doing it twice. So for my I, I'm taking my 10%, which that's the decimal form, dividing it by 2 and get 0.05. That's the percentage we're using each time period. Then if we're doing it for time, 11 years, but twice a year, this is 22 actual times we are working with this account. So now I just got to fill in all the pieces. 301 plus 0.05 to the 22nd minus 1 all over 0.05. It says how much will be in the account immediately after the last payment. $11,551.56. Do not think that you actually gained from $300 to $11,000. That is not what happened at all. You took your $300 and put it in there 22 times. So you actually put in there $6,600. So you gained about $5,000. Okay, you didn't actually gain from 300 all the way to 11,000. You gained only after you put in your $300 22 times. That's what annuity is. So every year an investor deposits $2,000 in an IRA, which earns interest rate at 6% per year. Well, if we're doing it once a year, though, our interest rate's not going to change. It's at 6%. And now its time's going to be after 10 years. So we don't actually have to change anything with this one. So 2001 plus 0.06 to the 10th minus 1, oops, all over 0.06. This is $26,361.59. Which this one doesn't seem that bad because you actually took 2,000, put it in 10 times. So you actually invested $20,000 in. You got $26,000 back. So you gained $6,000. Well, it was over a period of 10 years. I don't know how great that is. And the last one on this page, so it says how much should be invested every month at a rate of 6%. So we don't know R. R is the question mark. This 6%, we're doing it monthly. Divided by 12, and we get 0.005. And we want it for 19 months. Well, they didn't do years, so that's fine. We can keep that 19. And our A is 2,000, what we want. All right, so 2,000 equals some R, 1 plus 0.005 to the 19th minus 1, all over 0.005. Once you get this whole value here in your calculator, take 2,000 divided by it, and that'll give you R. R comes out to be $100.61. So roughly you would have to put in $100 every month in order to get $2,000 at the end. So you would actually only gain, it's like if you're putting $100 in for 19 months, it's like almost $1,900. And you want 2,000 at the end, so you're only really gaining like 80 bucks, truly. The present value of an annuity is a little different. They tell you right here in the question they want the present value of his winnings, so we know to use this formula. All the values are the same, though. There's an I, an R, and an N. So a person wins $3 million in the California lottery. It is paid in yearly installments of $500,000 for each 6 years. Okay, so that's our R, the $500,000. so $500,000 a year. Our I is at interest is at 5% compounded annually, so we don't have to divide it by anything. It's at 5%. And they want to know for 6 years, so our N is 6. So we start with our 500,000. 1 minus another parentheses, 1 plus 0.05, and negative 6, all over 0.05. Just plugging in pieces, really. And when we get at the end, $2,537,846.03. That's how much our present value of our winnings are. Next, student wishes to buy a car. You can afford to pay $400 per month. So that's our R. But has no money for down payment. If he can make these payments, that's a typo, payments, for 5 years, and the interest rate is 3%, what purchase price can he afford? Well, it is a monthly payment, so our I, 0.03 divided by 12, 0.0025. And time, we're 5 years, but monthly payments, so that's actually 60 payments. So 400, 1 minus 1 plus 0.0025, negative 60, all over 0.0025. This comes out to be $22,260.94. So this is roughly about what kind of car he can afford if he can make a $400 payment at this interest rate for 5 years. Installment buying. It's the last piece. We have a loan that's going to be paid on regular payments. We're trying to figure out what each size of our payment is. So this is a little, it's like the formula before, but it's just rewritten. Okay, so it's the exact same formula as before, reordered so that we can actually find the size of the payment. So if we have a person who's going to borrow $20,000 to buy a car and wants to pay it off in 4 years, so our A is the $20,000, our I, 8% a year, but we're doing it monthly, so divided by 12. That gets like a really long decimal, so just leave it like that. Then we are going to do it off in 4 years. So 4 years, 12 monthly payments, a year, 48 payments. So we have $20,000 times 0.08 over 12. That's a long decimal. Divided by 1 minus 1 plus 0.08 over 12 to the negative 48. Now careful with all your parentheses and your fractions and everything in here. You get 488.26 at the end. That's how much you could have your monthly payments be. Your monthly mortgage payment. If a couple borrows $100,000 at 3% as a mortgage loan on a house, which 3% is fantastic. In case you didn't know, that's a great percentage rate on a house. They expect to make monthly payments for 34 years to repay the loan. So our A is $100,000. Our interest rate is 0.03 divided by 12. That's another long decimal, so leave it like that. And time, 34 years and 12 monthly payments a year, and we get 408. Plugging the cell in, 100,000 times our interest rate divided by 1 minus parentheses 1 plus our interest rate to the negative 408. Once you type that all in, $391.27 is our monthly payment on a house, which doesn't seem too bad, but just remember, not only are you paying that monthly, you are also adding in your taxes monthly, and you're also adding in house insurance monthly. So your monthly payment for a house on a $100,000 home at 3% really is, you're paying $391 to the bank, but then it's also putting on your tax and your house insurance, so you're looking at probably about an $800 payment. It's usually about double, roughly, give or take a few 50s. And the last one, a car dealer sells a new car for $19,000. He offers the buyer a payment of $367 per month for 5 years. What's the interest rate? Well, our R is the 367. Our A is our 19,000. We don't know I. I is the question mark. But it is divided by 12, right? So it's like I over 12 is what we're going to use. Because it's monthly payments and time is 5 years, 12 payments a year, 60 payments. So I do 367 equals 19,000 times I over 12 over 1 minus 1 plus I over 12 to the negative 60. This is what you should do for this one. Right there, y1. This one, y2. We'll do that right now. It's going to be working with our, so 367. And on the other side, we have a fraction. 19,000 times x divided by 12. I might want to put that in parentheses. Oh, one too many spots. Oh, I have one too many nines. 19,000 x over 12. And on the bottom, 1 minus parentheses 1 plus x divided by 12, closure parentheses. Oh, I need a new parentheses because it's all to an exponent. Ah, here we go. Second insert parentheses. Now all the way back. Caret. Negative 60. Okay, window. 0. It is an interest rate, so it's got to be small. I'll do 10. Oh, no, I want 0 to 10. We have to see 367, so I don't know, we'll do 400 here. I have no idea what this is going to look like. Y scales by ones. X scales by ones. Graph. Yeah. Okay, I think we just need to make our window smaller for x's. Make this 1. Okay, or we could just go well, that's not a very nice looking graph. Where's my window at? I'll keep playing with it. I don't know what to tell you. Oh, whatever. The answer is 6% though. That is the answer, 6%, but you got to keep playing with your window. All right, that is